Hello humans, welcome back again. This is Code with Connor. We are doing the Let's Learn Python tutorial course. We are now in unit number 5, which is our last unit. Ooh, let me double check that. Yep, it's our last unit. So we are in our last unit, which is a big one. It's on data structures. This is kind of like everything's coming together into an important piece that lets us do a lot of other stuff in coding. Hopefully the Unit 4 project went okay for you and you managed to get through that little palindrome checker looping through the words. And we're going to jump into topic 5. We're going to start with tuples. Now, tuples are one of these things where it's like they have a niche, and there's going to be times when you're like, yeah, I love some tuples. And then when I'm going to teach you lists, you're going to be like, why would I ever use tuples? But don't get me wrong, there's still a great purpose for them, and we should definitely hit on them. It's just going to be a small lesson. So here I am in my file, and this is topic 1 for Unit 5. We're going to talk about tuples. Now, the important thing to understand about data structures, up to this point, every time we create a variable in our language, that variable is allowed to store one thing. And maybe we can change that thing, like we can store a string called mystra, and we can make it equal to hello, and then later we can reassign it to be equal to world, and that's all cool. Every variable we've created has only been able to be assigned one value, and that's where data structures come in, because that's not feasible. You can't realistically program these large-scale projects when every single piece of information has to have its own variable name. And that's when we get into data structures. And data structures allow us to have a single variable name that can contain a bunch of different values. And some of those values might be able to be reassigned if we're talking about lists. Some of those values might be now permanently stored within that data structure, like tuples. So that's what we mean when we talk about data structures. It's not anything crazy fancy. It's just it provides that flexibility that now we can have a single variable name, just one of them, but that variable name might allow us to reference a bunch of stuff. Think about strings and how we had a string, but technically we had a whole bunch of characters, and we could index and access individual characters within a string using just the string's variable name. Same idea here, but now we can control what's in these kind of lists or these data structures. So tuples use rounded brackets. They look something like this. So I have x as an input from the user. I'll just get rid of these ones. That was from when I was testing. So user inputs an x and a y. And then this is me creating a tuple. I called it chords. And you'll notice it's rounded brackets, comma separated values. This idea of comma separated values is the norm in data structures when programming. Okay, so here's the first comma, here's the second. All right, now all I'm doing is storing it and then printing it. I'm just printing the variable chords. So let's just run that real quick and then we'll go from there. So x, let's say 3y4, and then I could see it prints, rounded brackets, 3 comma 4. So it's printing the x and the y using the variable chords. Okay, now we can use index notation on this as well. So instead of printing chords, I could print chords box 0, which should only print the x. So x negative 1, y 5, and it only prints the x variable. Okay, because I can use that index notation to isolate one element within my data structure. Coming back over, we could do the same with box 1, where it would only print the y, or we could get a little fancier. We could do something like x, where we use the x and the y strings in combination with the items from the data structure. Now, because these are ints, we have to make sure we cast them to strings, because if we're concatenating them with other strings, it doesn't know what to do. And you'll see my error from before when I tried it and realized, because I also make mistakes. And there we go, x is 5, y is negative 1. So it's reading from that thing. And really, you're not seeing the power of data structures here. But if you had a long list of things that you wanted to reference, and then you want to be able to grab from that list throughout your program, you can create that list as a tuple, and then just a single variable name allows you to grab it. So imagine you're doing a hangman game, for example, and you want to have a tuple that has a whole bunch of puzzles in it. So it might have 100 hangman puzzles stored in it as strings. And then you want to have a random generator that picks a number within the size range of the tuple, and then it can just grab it right out of that data structure because it knows that it can use the same variable name and then an index with an integer to reference one of the puzzles. So things like that, you start to see the value in data structures versus having to have individual variables for all of these. And then how do you pick one Well, they all have different variable names. I can't just randomly pick a variable name, but I can randomly pick a number, and that number could be an index of a data structure, which then points to a string. So we start to kind of put it together like that. Now, really quickly, there's something called immutability that we need to talk about. So I'm going to bring something up here. Let's So immutability is going to be the ability for something to be able to be overwritten in memory or not overwritten in memory. So examples are all over the place, but a lot of times programming languages kind of fake immutability in that if you reassign a variable, it just points it to a different memory address, or if you have a bunch of things that all have the same value, technically the value is only stored in memory one place, but all the things are pointing at that same place, but they have the ability to point somewhere else if you change their value. And then there's things that are immutable, where it's like once we define them or once we initialize them, they're kind of set and those values are not changing. So tuples are a great example of that. So I've set the value of chords to be x and y. Now, x and y are variable names. They represent integers. So if I change the value of x and y, does that change the value of chords? So if I go x is now 20 and y is now 30, and I reprint the chords variable, will they change? Let's run it and see. So we'll set it to 2 and 0. So I see 2 and 0. But then between this line of code and this line of code, they should have changed value. But chords is still printing the old x value and the old y value. And that's a demonstration of that immutability that we were talking about. Even though these were variables when they were put into chords, when those variables got passed into this tuple, the tuple read the actual value of those variables and stored the value into the tuple. It did not store a reference to the variable. And so the variable can then change later on, and it does not change the tuple. Okay? So now one last thing before we move on from this. Let's say I try to manually change the value directly in my tuple. So I do chords box 0 is now 20, right? So I'm going to say, you know what? I want to override that value. Forget that it's a variable, not a variable, whatever. I need to change it in my tuple. Let's run this, and it doesn't like it. It says type error, tuple object does not support item assignment. So once you set up your tuple, it's set up. Right? That's that immutability piece. And that's where we'll see more flexibility when we look at strings. That's where we'll see the flexibility of using lists versus tuples, is we have the ability to assign and change values dynamically. Okay, so that's kind of an intro crash course with data structures. Let's look quickly at the challenge for this lesson, which is not super practical because you wouldn't normally use tuples for something like this. But you know what? It kind of proves the point of what we're doing, and that's okay. Sometimes that's all we need to do. So here's our challenge. x1, let's do 0, 0 for x and y1. And then a secondary point. So let's do 5 and 2. And then it calculates the slope of the line. So remember your slope formula, and you Google it if you need to. It's y2 minus y1, all divided by x2 minus x1. Okay? Now, what I want you to do, and again, not necessary, but for the sake of practicing tuples, store the first point as a coordinate, store that first point, the x1, y1, as a tuple, store the second point, the x2, y2, as a tuple, and then use the tuples with index notation when doing your slope calculation. And that's just a good way to test and make sure we're using that tuple stuff correctly. All right. So good luck with the challenge. We're into topic 5. This is the data structures unit. We're almost there. And we'll see you back here for lesson number 2 very soon. Don't forget, like, share, subscribe, and good luck with your coding. See ya.